Dear students, in this video we are going to see 5.1 and 5.2. What is 1 divided by 1 plus x is nothing but 1 minus x plus x squared minus x cubed plus etc. This is nothing but sum of the series which is denoted from n is equal to 0 to infinity minus 1 to the power n multiply x to the power n. Similarly, we can write sum of this series like this. Now find the sum of the following convergent series, that is sigma j is equal to 0 to infinity I over 3 whole to the power j. Here we have to find the sum of the given series. Okay. So now what is this? This is nothing but sigma j is equal to 0 to infinity. We can compare this with the general form like x to the power n. Okay. So what is the sigma n equal to 0 to infinity x to the power n? That is nothing but 1 over 1 minus x. Here what is x is nothing but I over 3. So that I can write this given sum is nothing but 1 over 1 minus x is I over 3. So you write here I over 3. Then you multiply this 3 with 1. So 3 minus I over 3. Then write the reciprocal value of this, that is 3 over 3 minus I. Then what you do, you take the complex conjugate of this denominator value, because this is the complex number in the denominator, so that you take the complex conjugate, then multiply in the numerator and in the denominator, then you simplify it, you will get this complex number in the form of a plus ba. This is nothing but sum of the series I over 3 whole to the power j from 0 to infinity. Okay, that's it. Now we'll say another question. What is the second question? Sigma j is equal to 4 to infinity minus 1 power j to I divided by 3 whole power j. Okay. Now first here we substitute j is equal to 4 in the given term. Then j is equal to 5. We will expand. Now you see here what is first value of j, that is 4. So you put here minus 1 power 4 to I by 3 power 4. Similarly you put j5, j6, j7, etc. Okay. Now you see here in each term what we can take as a common factor, we can take minus 1 over minus 1 power 4 to I by 3 power 4. So we can take this in each term. So that here if you take this as a common factor, so here you will get 1 in the first term. Plus here we are taking degree 4 outside, so that the remaining is here degree 1. So minus 1 power 1, here 2I by 3 power 1. Similarly you write here power 2, power 3, etc. Okay. Now after this you compare this with the general rule. Now you see here 1 minus x plus x squared minus x cubed plus etc. Okay, this is nothing but sigma n equal to 0 to infinity minus 1 power n x to the power n. Okay, here you see the changes in sign, okay, in alternate terms. Okay, so that now we apply this rule here. See here minus 1 power 1 is minus 1 power 2 plus minus 1 power 3 minus, so that here we get 1 minus this, consider this as a x, 1 minus x power 1 plus x power 2 minus x power 3. Okay, so this is x, the value of x is 2I over 3. So that what we can write here, if this is the series 1 minus x plus x squared minus x cubed plus etc., this is the summation form which is equal to 1 over 1 plus x. So that we are going to write 1 over 1 plus x in the given problem. Now so that minus 1 power 4 2I by 3 whole power 4 outside, this is nothing but 1 over 1 plus x, x is 2I over 3. Okay, so that here you multiply 3 with 1, so 3 plus 2I by 3. So that here we can write the reciprocal of this one, which is 16 over 81, multiply the reciprocal of this is 3 over 3 plus 2I. Now what we have to do, see, we have to take the complex conjugate of this, then here multiply in the numerator and in the denominator, then simplify it, you will get finally a plus ib form. That is your final answer of this given series. That's it. Now we see here comparison test. What is this? Suppose the real numbers mk is greater than or equal to 0 and sigma k is equal to 0 to infinity mk converges, which means now we can conclude that if modulus means absolute value of zk less than or equal to mk, less than or equal to mk means this real numbers for every k, then we can say that sigma k is equal to 0 to infinity zk converges absolutely. This is the comparison test. Now we see the question for this comparison test. Now you see here, does the series converge or diverge? Okay, what is the given series? Sigma n equal to 1 to infinity 3 plus cosine n over e to the power n. Okay, now what we do here, we are going to check whether it is converge or diverge by comparison test. Now see the numerator value 3 plus cosine n. Okay, here n varies from 1 to infinity. Okay, so that 3 plus cosine, so modulus value of 3 plus cosine n, so what will be the maximum? That is 4. Okay, see here n varies from 1 to infinity, which means see this is 3 plus here the maximum of this is nothing but 4. That's why we are writing modulus of 3 plus cosine n is less than or equal to 4. Okay, now you combine this with the denominator, see, which means you take the whole value. Okay, now 3 plus cosine n by e to the power n modulus is equal to nothing but 3 plus cosine n divided by e power n less than or equal to 4 over e power n. Okay, because we conclude that this is nothing but less than or equal to 4. So that here this equal to 4 times 1 over e whole to the power n. Okay, what is 1 over e? 1 over e is always less than 1. We know that. What is e? E is 2.7 approximately. So 1 over 2.7, that definitely this is less than 1. Okay, so now what will happen here? The whole value 4 multiply 1 over e whole to the power n, what will happen? Definitely this will converge because 1 over e is less than 1. So that now the sigma 4 1 over e whole to the power n will converge. Okay, so that now by comparison test what we can conclude that sigma this 3 plus cosine n over e to the power n also converge. Okay, so this is the conclusion, so that we can say that this given series converges absolutely by comparison test. See, we see here the ratio test. What is the ratio test? Suppose when series is given, how we can confirm that through ratio test the given series is converge or not converge? If it is not converge, then how we can confirm that? Suppose the given series is not diverge, not converge, then what is the final decision we can say? So that here by ratio test we can classify that. Okay, that is, see, we have to find first limit n tends to infinity a n plus 1 by a n. Okay, the modulus value of a n plus 1 by a n, that is nothing but we assume that some value L. Okay, this value is L. Okay, then if L is less than 1, sure the given series is convergent absolutely. If L is greater than 1, definitely the given series is not convergent, which means divergent. If L is equal to 1, then it is inconclusive. That is ratio test. Now we will see few problems how to confirm, how to check the given series is convergent or not convergent through ratio test. Using the ratio test, show that the following series converge. Okay, so we have to prove that the given series are converge. Okay, by using the ratio test. Okay, now what is the first question? That is summation k is equal to 1 to infinity k over 5 to the power k. Okay, now we will take this as ak is equal to k over 5 power k. Okay, so now by ratio test, to use ratio test, what we have to do? We have to find this value. What is that? Limit n tends to infinity modulus a n plus 1 divided by a n we have to find. Okay, we are telling that this value is L. Okay, now here what is given? That is ak. We take that ak. So here what we are going to find, that L is equal to limit k tends to infinity ak plus 1 by ak. Okay, now this is ak. We know that ak plus 1 means, now here put k plus 1 divided by 5 to the power k plus 1 in the numerator. That's what we are doing. So limit k tends to infinity. Now ak plus 1 means in the given expression you replace k by k plus 1. Okay, that is here in the numerator. So what is in the denominator? Ak, which means now what is given in the summation, you write that ak. Okay, now what you do, you simplify it. Now here see, you take the reciprocal of this, write the reciprocal of this. That's why see here k plus 1 by 5 power k plus 1, and then this is 5 power k by k. Okay, now here we can cancel 5 power k and 5 power k. So here 5 power 1 is remaining. Okay, so now you see here what is here. So in the denominator 5 is remaining. That's what we are writing here, 1 over 5. Okay, now here what happened on k plus 1 divided by k, that is here you take one k as a common factor, then k and k cancel, then you apply the limit. Understand, you apply the limit, so that here you will get 1 over k, that 1 over infinity is 0, so this will be 0. So what is the remaining here? So that what will happen here, it will become 1, this value will become 1. Understand? So that now what is remaining here, there is no k. Okay, so 1 over 5 is the final value. So what is L? So what is L? L is nothing but 1 over 5. So which is equal to 0.2, which means L is less than 1. So what is our conclusion? Now you see here, if L is less than 1, then definitely the given series is absolutely convergent. That's why here we are writing that here L is less than 1, therefore the given series is convergent. That's it. Now you see the second question. Sigma n is equal to 1 to infinity 3 plus I to the power n divided by n factorial. Okay, now you take it as an is equal to 3 plus I or power n divided by n factorial. Okay, what the ratio test says, we have to find limit n tends to infinity modulus an plus 1 by an, then fix that is L. Okay, now here what is an plus 1? See here, put here in an you replace n by n plus 1, so that is an plus 1. That's what we are doing here. So 3 plus I whole to the power n plus 1 divided by n plus 1 factorial. Okay, in the denominator you write an, in the denominator you write the same an. Okay, now you write the reciprocal of this. That's why 3 plus I whole power n plus 1 by n plus 1 factorial is same here. This denominator value you write as reciprocal, so n factorial divided by 3 plus I whole power n. Okay, so 3 plus I whole power n, 3 plus I whole power n will be cancelled. So what is remaining here? 3 plus I power 1 remaining, so that's why I'm writing 3 plus I. N plus 1 factorial is nothing but n plus 1 multiply n factorial. So n factorial cancel, so that's why I write n plus 1. Okay, now see, that's what I written here. N plus 1 factorial is nothing but n plus 1 n factorial. So that here n factorial will be cancelled, so n plus 1 remaining. Okay, so now what is this? You see here, limit n tends to infinity. Okay, so that if you put n, means here n tends to infinity means this denominator means 1 divided by n plus 1 becomes 0. So that the limit L means the value of L, which means this value will goes to 0. Okay, this entire value will goes to 0 as n goes to infinity. Okay, so that here L is going to infinity, which means L is less than 1. L is less than 1. That is our conclusion. So that we can say that this series is also convergent. Okay, so how we conclude convergent? Because by ratio test, if L is less than 1, then the series is absolutely convergent. Okay, so that here we can conclude that this value that is L is going to 0, tends to 0 as n tends to infinity, which means L is less than 1. Okay, so that the series is convergent. That's it. Now the continuation of this lecture we will see in the next video. Thank you.